Hello and welcome to a new section on cracking 64-bit programs. In this first introductory lecture, I would like to introduce you to 64-bit registers. Modern CPUs all have 64-bit registers. However, for backward compatibility, it is still capable of 32-bit addressing, and we have been using the 32-bit addressing so far in this course until now. The register names are as follows. What we have seen so far is the EX register and parts of it. For example, EX is 4 bytes or double word, also known as D word, and it is 32 bits. And it is also possible to subdivide it into a word, and a word is 2 bytes, consisting of the higher byte and the lower byte. And higher byte is AH, which is 8 bits, and the lower byte is AL, which is 8 bits. And then for 64 bits, it is double the size of EX. And so for 64 bits, it is 4 bytes and 4 bytes, so a total of 8 bytes, or 64 bits. And the naming convention is as such. For the lower bytes of the AX register, it is called AL. And then for the higher byte is AH. And then for the EX is called just EX. And if you are going to address the entire 64 bits, then we will say RAX. So this is the naming convention. And the same naming convention holds true for the other registers as well. So, a comparison between 64-bit and 32-bit instructions. In the 32-bit addressing, you will write the instructions to move 10 into EX as follows. And you will also add 20 to EX as follows. And in 64-bit, you will do the same thing, but now you will change the name of the register to RAX. So basically they are identical, they are the same. The only difference is EX is 32-bit and RX is 64-bit. And the same holds true for all the other registers as well. And here is a table of all the comparison between the addressing modes. If you are addressing the entire 64-bit of a CPU, the register, then you will call the register names as RAX, and if you are addressing the 32 bits, you will call it EX, and if you are addressing the lower bits, lower 16 bits, it will be EX, and the lower 8 bits as AL. Now if you read this and compare it with this diagram here, then you get a better understanding. And the same thing happens for RBX. And all the way to RDX. And then here we have ESI, and the new name for ESI is RSI for 64-bit. EDI now becomes RDI. EBP now becomes RBP. ESP, the stack pointer, now is RSP. And these are new registers found only on 64-bit addressing modes. R8 to R15. So the 64-bit register addressing has got new registers, R8 to R15. So in 64-bit addressing, when we are dealing with 64-bit programs, we have the advantage of these additional registers. Remember that. And then we have all these new names coming up. For the lower bit, RAD. For the lower 16-bit, RAW and RAB, and so on. Now, of importance to note is passing arguments to functions. There are 3 ways of passing arguments to functions. Method 1 is to use register, which is something like this. When you want to call a function, you will move the parameters of the function call into the register, and then you will call the function. The function will then make use of the registers directly. Secondly is to use global data method 2. In global data, we will have a data section which stores the arguments or the parameters. And then when you are going to call a function, you will then initialize those global data with values by moving the values into those global data. And then you call the function will directly access those global data. In the third way, we use the stack, and this is quite common, and as you have seen many of the programs using this method. So using the stack where we push arguments for the function into the stack. For example, if we want the function to make use of these two values, we will push 5 and push 2 to the stack, then we will call the function, and the function will then access those values from the stack. So these are the three ways of passing arguments to functions. Now the reason why I brought this up is because in 32-bit programs, passing arguments through the stack is more common because of the less number of registers. But in 64-bit addressing, it is more common to pass parameters using registers because 64-bit programs have the additional registers R8 to R15. So in 32-bit, we don't have this extended number of registers. So that's why this is important to note. You will be seeing a lot of 64-bit programs passing arguments to the functions by using registers like this, more common than passing over the stack. That is all for this lesson. I will see you in the next lesson. Thank you very much.